Tiantu from the ashes of a broken continent. Imagine a silhouette that consumes the entire horizon. Through the thick, churning fog of the Garsweiler mine, a shape emerges that defies the very vocabulary of modern engineering. It is a structure so vast it seems to possess its own gravity, a steel titan that moves with a slow, rhythmic, and terrifying certainty. This is the Bagger 293. To the uninitiated, it looks like a city that decided to walk. But before it was a record-breaking marvel of the 21st century, it was a desperate dream born from the darkest chapter of the 20th. To understand the Bagger, you must first understand the silence of a continent in ruins. Germany, in the immediate aftermath of the Second World War, was a landscape defined by absence. Its factories were hollowed-out shells. Its power grid was a tangled web of cold copper and regret. The mandate for the German engineers of the late 1940s was singular and crushing. Provide the energy to rebuild a broken nation or perish in the cold of a bankrupt winter. The prize was lignite coal, soft, brown, and buried beneath hundreds of millions of tons of stubborn, wet earth. The old methods of the previous century, the steam-driven shovels and the labor-intensive cable machines, were failing. They were relics of a slower, more deliberate world, utterly incapable of the sheer volume of material required to ignite a dead economy. These engineers, men who had seen their world demolished, watched these traditional machines, great iron beasts that dug, swung, dumped, and then halted. And they saw a fundamental flaw: the pause. To resurrect a nation from the ashes, they couldn't afford a machine that stopped. They needed a continuous flow, a mechanical river of earth that never ceased its motion. They stood amidst the literal rubble of their industry, tasked with inventing a way to move the very ground they stood on at a scale that had never been whispered in an engineering hall. They weren't just looking for a bigger digger, they were looking for a way to turn the crust of the earth into an assembly line. This was the birth of the mobile factory concept, a vision born from the grim necessity of a shattered land. They would build something that didn't just mine the earth, but consumed it. The bucket wheel epiphany. To understand the Bagger 293, one must first understand the fundamental failure of the traditional shovel. For decades, the industrial standard for open-pit mining was the cable-operated power shovel. It was a machine defined by a rhythmic yet stuttering cadence. A massive bucket would bite the earth, swing through a 90-degree arc, dump its load into a waiting rail car or truck, and then swing back to begin the process again. This was a dance of inertia. Every time a 50-ton shovel arm stopped to change direction, kinetic energy was bled off into heat and mechanical stress. For the engineers at Krupp in West Germany and Takraf in the East, this was more than an inefficiency. It was a logical insult. They realized that if Germany was to rebuild using the lignite buried deep beneath the Rhineland, they couldn't just build a bigger shovel. They had to redefine the act of digging itself. This realization led to what we now call the bucket wheel epiphany. The shift was from batch processing to continuous flow. The engineers looked at the wheel, humanity's most fundamental invention, and reimagined it as a rotary cutting head of gargantuan proportions. Imagine a wheel the size of a 5-story building, mounted on the end of a cantilevered steel boom. Instead of one bucket doing all the work, you have 18, 20, or 30, arranged in a perfect, unyielding circle. As the wheel rotates, each bucket takes its turn carving a precise slice of the earth. But here is the genius of the geometry. As the bucket reaches the top of its rotation, gravity takes over. The soil falls out of the bucket and onto a series of conveyor belts that run through the very heart of the machine. The digging never stops. The swing never stops. The flow of material becomes a constant brown river of energy. It was the industrial assembly line, liberated from the factory floor and set loose upon the landscape. The technical hurdles to realizing this vision were staggering. This wasn't merely about making a big wheel, it was about managing the terrifying forces of torque. The wheel had to spin slowly enough to allow the material to discharge via centrifugal force and gravity, yet it required enough raw power to shear through compacted clay, sandstone, and frozen earth. The gearboxes required for this task were masterpieces of heavy metallurgy, massive, oil-bathed planetary gear systems capable of translating thousands of kilowatts of electrical power into the slow, grinding rotation of the wheel. The early prototypes were met with skepticism by the global mining community. Critics dismissed them as clockwork nightmares. They argued that the complexity of the wheel, the conveyor transfers, and the rotary bearings created too many single points of failure. They claimed that a single mechanical hiccup would paralyze the entire operation, whereas a fleet of traditional shovels offered the safety of redundancy. However, the German engineers, driven by a post-war necessity to maximize every kilowatt of energy, doubled down on the complexity. They didn't just design a wheel, they designed a system of mechanical persistence. They utilized high-tension, low-alloy steel and pioneering welding techniques to ensure the booms could withstand the lateral stresses of slewing, the side-to-side swinging of the entire superstructure while the wheel was under load. They developed bucket teeth made of tungsten carbide, capable of grinding through almost anything the earth could hide. To power these leviathans, they moved away from steam and toward high-voltage electrical architecture, feeding the machines through thick, trailing cables that carried enough juice to power a small city. By the time the first true giants began to crawl across the German landscape in the 1950s and 60s, the mockery had vanished. The output numbers were undeniable. A single bucket wheel excavator could move more earth in a shift than a battalion of traditional shovels, and it did so with a mechanical grace that seemed impossible for its size. This was the era where the philosophy of the mobile factory was solidified. The engineers realized that the excavator was merely the head of a massive living organism. If the wheel was the mouth, the conveyor systems were the veins, and the spreaders were the lungs. This shift in thinking, from digging to continuous material handling, is what paved the way for the eventual construction of the Bagger 293. It was a triumph of relentless, circular momentum over the crude back-and-forth struggle of the past. The bucket wheel didn't just move the earth, it conquered the very idea of resistance through the sheer, unyielding logic of the circle. The philosophy of the mobile factory. To look at the Bagger 293 is to witness more than a machine. It is to behold a philosophy of total industrial integration. By the mid-20th century, German engineers had realized a fundamental truth that would change the face of terrestrial excavation. Digging is only half the battle. If you design a wheel capable of biting through 240 tons of earth in a single day, you have created a logistical nightmare. You have created a mountain of material that, if not moved instantly, will bury the very machine that produced it. This was the birth of the mobile factory concept. The engineers at Krupp and Takraf didn't just want a bigger shovel. They wanted a continuous, unstoppable flow. This required the development of the bagger conveyor spreader triad. In this ecosystem, the bagger is the mouth, but the conveyor belts are the veins. These are not the simple rubber belts you see at a grocery store or even a standard factory. We are talking about steel-reinforced cord belts traveling at speeds that would make a sprinter gasp, stretching for miles across the lunar landscape of the lignite mines. These belts had to be as mobile as the machine itself, shifting and pivoting as the bagger advanced. This level of synchronization requires a no-compromise engineering culture. It is a culture where good enough is viewed as a precursor to catastrophe. This mindset was tested most fiercely when the engineers faced the primary enemy of all terrestrial giants: gravity. The Bagger 293 weighs roughly 14,200 metric tons. To put that in perspective, that is the weight of over 80 blue whales concentrated into a single footprint. When you place that kind of mass on the soft, rain-soaked soil of a German open-cast mine, the laws of physics dictate that it should sink like a stone in a pond. The solution was a masterclass in surface area distribution. The engineers designed a custom crawler system consisting of 12 massive tracks, each nearly 4 meters wide. By spreading those 14,010 tons across such a vast surface area, they achieved a technical miracle. Despite its moon-sized mass, the Bagger 293 exerts a ground pressure of less than 1.7 kilograms per square centimeter. In layman's terms, this mechanical leviathan exerts less pressure on the Earth than a human being standing on 1 foot. It is this level of meticulous, obsessive detail that separates German heavy engineering from the rest of the world. It is the refusal to accept the limitations of the environment. If the ground is too soft, you do not build a smaller machine. You redefine how weight interacts with the Earth. If the distance is too great, you do not use more trucks. You build a bridge of rubber and steel that never stops moving. For those of you watching who appreciate this level of uncompromising design, the tradesmen who know the value of a tool that never quits, and the engineers who live for these decimal points, this is your world. If you respect the grit and the genius required to move the Earth itself, hit the subscribe button. We are documenting the history of the titans that power our civilization. This diversification of technology turned the mining site into a living organism. At the end of these miles of conveyors sits the spreader, or absetzer. While the bagger consumes, the spreader creates, meticulously backfilling the excavated areas to allow for future land reclamation. It is a closed loop of titanic proportions. This wasn't just about extraction, it was about the total management of the Earth's crust. The German engineers understood that to dominate the scale of the mine, they had to think like architects of a moving city. Every joint, every hydraulic line, and every gear in the massive slewing ball racing had to be over-engineered to withstand forces that would shear standard industrial equipment in half. This is the silent titan philosophy, building something so robust and so well-planned that its operation feels inevitable. The Bagger 293 doesn't just work, it persists, a testament to an era where humans dared to outscale nature itself through the sheer force of calculated will. Bagger 293. 93. The Silent Titan. The lineage of the bucket wheel led here, to the apex of industrial evolution. In 1995, the culmination of decades of research, failure, and refinement took physical form. It was designated the Bagger 293, but to those who stand in its shadow, it is simply the Titan. At 14,200 metric tons, it does not merely occupy space, it alters the landscape's center of gravity. It spans 225 meters, over 2 full football fields in length. Standing nearly 100 meters tall, it towers over the rim of the Garsweiler mine like a cathedral built of lattice steel and hydraulic fluid. It is the heaviest land vehicle ever recorded by man, yet it moves with a deliberate, haunting precision. The 293 is a beast of consumption. Its heart is the massive bucket wheel, a 21-meter disc of rotating devastation. 18 buckets, each capable of swallowing 15 cubic meters of earth in a single pass, bite into the seam. It does not just dig, it erases the earth. In a single 24-hour shift, it relocates 240,000 cubic meters of overburden. To visualize this, imagine a standard American football field. Now imagine digging that field down 30 meters deep, the height of a 10-story building. Bagger 293 performs that task every single day, day after day, year after year. The engineers at Takraf who birthed this machine did not just design a tool. They designed a sovereign entity. A crew of only 5 people is required to operate this 14,000-ton Leviathan. They sit in cabins that feel like flight decks, managing the intricate dance of the wheel, the conveyor belts, and the crawler tracks. There is a profound silence in its operation, save for the low-frequency hum of massive electric motors and the rhythmic thrum of the earth being deposited onto the high-speed belts. It is a factory that breathes coal and exhales progress. Why build something so gargantuan? Because the German engineering mind rejects the inefficiency of the small. To power a modern industrial nation, the scale of the solution must match the scale of the demand. The 293 represents a refusal to be limited by the physics of the past. It is the manifestation of the Industriekultur, the belief that through rigorous mathematics and uncompromising construction, humanity can bend the very crust of the earth to its will. The machine is not just a triumph of size, but a triumph of integration. Every component, from the smallest bolt to the massive counterweights, works in a closed-loop system of efficiency. It is the ultimate evolution of the mobile factory concept first envisioned in the post-war ruins. Today, the Bagger 293 continues its slow, majestic crawl through the German landscape. It is more than a machine. It is a monument to the era of steel. It serves as a reminder to every tradesman, every operator, and every engineer that the only limits we face are those we fail to rethink. As it cuts into the lignite seams, it writes the final chapter of a story that began in the ruins of a broken continent. A story of how German ingenuity did not just rebuild a nation, but built the largest machine the world has ever seen. The Silent Titan remains, a testament to the power of the collective human mind to dream in 14,000 tons of steel. It is the manifestation of a philosophy that states, no problem is too large if you are willing to rethink the scale of the solution. When we look at the Bagger 293, we are not just looking at a digger. We are looking at the peak of terrestrial engineering, a machine that turned the impossible into the routine.